Okay guys, so today we're going to see at exercises 8, 9, and 10 from your paper 1 from last week, the mock exams that you guys took. Number 8 says, a line L1 passes through those 2 points. I want you to find the direction AB. It's a vector. You're working with vectors, guys. Remember that to find a vector, you take B and you subtract A. All right, so to find AB, all you would have to do is 2b, 3, 5, 2, you would have to subtract 0, 1, 8. And that's how you get 3, 4, and minus 6. For the second one, guys, it says write down a vector line for L1. Remember, guys, that vector lines have to be in the form A plus TB, where A can be any point on the line, and B must be the direction. All right? The direction in this case, guys, it's AB. So we already have the direction, and the point can be any of these two, A or B. So that way, if you substitute the value of A and the value of B, you have these options. R can be 0, 1, 8 plus T times 3, 4, minus 6. Or, if I use the other point, I would have 3 plus 3T, 5 plus 4T, and 2 minus 6T. These are two different ways of expressing the line, guys. Either one is correct. Letter B says that a second line, L2, has that equation, and you need to prove that P is equal to 2, knowing that L1 and L2 are perpendicular. Remember, guys, that for perpendicular lines, the scalar product must be equal to 0. In this case, since we are working with lines, you need to identify that you have to work with the direction vector. The direction vector, guys, it's always the vector that it's multiplied by the variable s or t. Those are the ones that are usually written. All right? So, if I know that L1 is the one that I found in A, because you already have it, and L2 is this one, well, you have the direction of the first one, which is 3, 4, minus 6, and you multiply it times the direction of the second line, which it's P0, 1, and you know that it has to be equal to 0 because it's telling you that they're perpendicular. With that, knowing that, guys, then you know that you would have to do 3P plus 4 times 0 plus minus 6 times 1, and it has to be equal to 0. I solved this equation, and that's how you show that P is equal to 2. This is your showing, guys. Showing means that you don't use what they give you, but you have to know that you have to arrive to that value. All right, letter C says, guys, for you to find the point of intersection of line 1 and line 2. They're already giving you the value of x and the value of y. But if we didn't know x and y, then we know that R1 and R2 can be expressed this way. X is equal to 3t, y is equal to 1 plus 4t, z is equal to 8 minus 6t. Remember, guys, that this line represents x's, the second one represents the y's, and the third one represents the z's. Same thing for line 2. That's how you get that x is equal to 1 plus 2s, y is equal to 13, and z is equal to minus 14 plus s. Since they have to intersect, guys, then I equal them. 3t must be equal to 1 plus s plus 2s. 1 plus 4t must be equal to 13, and 8 minus 6t must be equal to minus 14 plus s. From this system of equations, guys, you can find the value of one of the variables. In this case, it is much easier for me to find the value of 2 from this second one. So the value of t, you would have to find the value of t, and you isolate for t, and you get that t is equal to 3. Okay? If I know that t is equal to 3, guys, if I were to find the value of s, then you can take whichever equation and substitute the value of t in there, and you can get the value of s. So in this case, I took the first equation and substituted the t with a 3, and I have that 3 times 3 is equal to 1 plus 2s, and that's how you get that s is equal to 4. Now, I didn't really need to find it for this exercise, but I did anyways. All right, why didn't I really need to find it, guys? Because I already know the value of t. So if I substitute the value of t in here, 3t, 4t, and 6t, I can get the point. 3 times 3, 1 plus 4 times 3, and 8 minus 6 times 3. I could have done the same thing if I would have found the value of s. If you find the value of s, you substitute them in this 3, and you're going to get the exact same point because it's a point where they intersect. And so my point of intersection is 9, 13, and minus 10. And the last question with respect to vectors, guys. Letter D asks for you to find a unit vector with the direction of L2. So remember that when we're working with lines, guys, you take the direction vector. So I take 2, 0, and 1, and that's the vector that I'm going to be working with. To find a unit vector, guys, remember that you have to find it by doing the vector times 1 over the magnitude of that vector. So first thing I need to do is find the magnitude. The magnitude is found by doing the square root of 2 squared plus 0 squared plus 1 squared. And that's how I get that the magnitude is the square root of 5. If I multiply the vector times 1 over the square root of 5, this would be a unit vector. I can leave it expressed this way, guys, or you can literally multiply them and you would get this new vector. All right, so now, guys, it is asking for you to find one point on L2, which is the square root of 5 units from C. There's two different ways of doing it, but I'm going to show you first how to do it using the unit vector. If you take the point 9, 13, and minus 10, and if you add the square root of 5, guys, you would get a point that it's square root of 5 units away. The thing is that we cannot multiply a vector, we cannot add a vector with a number. We would have to have a vector adding or subtracting another vector. So in order for us to turn this square root of 5 into a vector, we can multiply times the unit vector, and that way we can get a new vector. So if I multiply this square root of 5 times the unit vector that I found on the top, I'm going to get the vector 2, 0, and 1. And if to the vector or the vector point or the position of the point, which is 9, 13, and minus 10, I add or subtract 2, 0, and 1, I'm going to get a vector that it's square root of 5 units away from 9, 13, and minus 10. So you have two possible answers, 11, 13, and minus 9, or 7, 13, and minus 11. All right? That's one way to do it, and I think that's the easiest one, but there's another way to do it. I can do it by finding the distance between points. So you got to remember, guys, that we would have to find the direction vector between this line and this point. To find the direction vector, you would have to do the subtraction of those vectors. So I would have 1 plus 2s minus 9, 13 minus 13, and minus 14 plus s minus 10. And you get this new vector right here. You find the magnitude, guys, but you find the magnitude and you equal it to the square root of 5 because you know that this vector has to be square root of 5 units away. All right, so it has to be the length of that vector. And so when you do this equation, when you solve this equation, you get 2s minus 8 squared plus s minus 4 squared, it's equal to 5. And you develop this equation all through like what you already know, 4s squared minus 32. This right here, guys, it's the expansion of this binomial. And this right here, it's the expansion of this binomial. I put terms together. I end up with a quadratic equation. I'm going to factor out a 5. And s2 minus 8s plus 15, I can factor it into s minus 5 and s minus 3. And so I get that s can be 5 or s can be 3. All right? With that in mind, then I substitute into the line because it says that the point must be on the line. So I substitute in this line the value of 5 and the value of 3. And 1 plus 5 times 2 gives you 11. 13 plus 5 times 0 gives you 13. Minus 14 plus 5 times 1 gives you minus 9. Same thing, the second one, multiplying times 3. You would get 7. 13 and minus 11. And that's how you get, guys, the same answer as we got it on the first method that I showed you.